All right, first one, domain and range. What are they? Both elements of the reals. Excellent. And the second one, domain. Also everything. What would the range be? Greater than 1 or equal to. Perfect. No problem. We're going to skip the construct the understanding and then go here and highlight a definition. A radical function is you take any of the functions that we can already graph. So you've got all your x squared and x cubed and what other ones have we done? Sine and cos and logarithms and exponential ones like 5 to the x. Any one that you know how to graph and you put it inside of a square root. So any function that you know how to graph, which I've highlighted in yellow, could be put into a square root, and we're going to learn how to graph the square root of any graph that you already know. And of course, we already know the square root of x graph. This was one of our graphs. So another thing that, since you know how to graph the square root of x graph, you will learn how to graph the square root of a square root of x graph if you wanted to as well. And we'll learn what that looks like. But here's our basic radical function, which is the square root of x. Now, what we're going to do in this unit is we're going to say there's two ways that you can graph the square root of x, because you already know that it looks like this. But in this unit, what we're going to look at is say, I know that the graph of y equals x looks like that. That's a straight line. It has the point 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on. Okay? And all the graph of y equals square root of x says is you take the points that you know on the graph before and you square root them. So for example, you had 4, 4. What happens when I square root the y value? I get 4, 2. Which you're saying, Mr. JR, if I already know how to graph this, why are you showing me a different way? I can understand that, but we're going to be doing some other graphs that you wouldn't know how to graph the square root of them. So I'm showing you that if you could graph the inside, then all you have to do with a square root graph is take the square root of the y values. So another one that's easy to square root is this point 1, 1. Can you see that that would stay the same? My 4, 2 point looks a little low, doesn't it? Just make it bigger. Now, a couple of things that we're going to learn in this unit is whenever you square root a number between 0 and 1, something happens. And whenever you square root a number bigger than 1, something happens. So we're going to just do a summary off to the side. Between, there's 2. And what happens when you square root bigger than 1? Now, we'll start with the bottom one. Whenever you square root something bigger than 1, like square root of 4, or square root of 9, or square root of 15, even a number that doesn't work, you always get an answer that's less than what you started with. Does that make sense? Square root of 9 is 3. You started with a 9. You got an answer that's less than what you started with. Okay? And for the most part, up till now, in your head, you might think that that always happens with square roots. Because chances are that's the only kind of square roots you've ever done. Has anyone done a lot of square roots between 0 and 1? Like, oh, just, oh, I feel like doing square root of 0.3 and see what happens. Or do the square root of 0.9 and see what happens. Chances are, for the most part, you've only done square roots of numbers bigger than 1. So in your mind, it's obvious that when you take the square root, you always get something less. But that's not always the case. Because if you take the square root of 0.64, you get 0.8. If you take the square root of 0.49, you get 0.7. And whenever you take a square root between 0 and 1, it is bigger than what you started with. So between 0 and 1, it's bigger than what you started with. After 0 and 1, it's smaller than what you started with. And the one thing I didn't include here was less than 0. What happens when you take a square root of something less than 0? You can't. It's not possible. So what we're going to find out is we're going to be able to graph the inside of the graph first. So here's y equals square root of x. I graphed y equals x first. Anything that was bigger than 1 for y values, and here's 1 on my graph, this part of the graph, all these points would be less and below our graph. But whatever is between 0 and 1 will be bigger. So our graph is above our graph there and then below it afterwards. And that probably you can see it even better if I draw the line y equals x on here. Probably should have chosen a different color. Yellow. So you can see that the red graph is above it there and below it afterwards. So this is going to be an important thing that they're going to look for on the final exam is, do you have the points above when it's between 0 and 1 and below after? And the other thing that's going to be important is when it's 1 and when it's 0, those points stay the same. Because the square root of 0 is 0 and the square root of 1 is 1. So these 2 points at 0 and at 1 stay the same. And so here they have a couple more examples of graphs that we've done in the past. Now, for something like this, the square root of x plus 4, I would say, you know what the square root of x graph looks like. You know how to do transformations. X plus 4 would move it 4 to the left. So I would just take my square root of graph and move it 4 to the left, and you would get the blue graph, and that would be perfect in this situation. This is showing you that if you graph the inside first, if I graphed x plus 4, which is a y-intercept of 4 and a slope of 1, I would get this red line. I would then show where it's equal to 0 and where it's equal to 1. And then when I graph my graph, I would say this point's in common, this point's in common. When the y values are between 0 and 1, my graph is a little bit above. And then after that, it's below. I would probably label one more point because I know my y value here is 4. The square root of 4 is 2. So I would label this point 0, 2. But you're always going to have to label the points where it's equal to 0 and equal to 1. Same thing here. This is actually one that you might make a mistake if you use your transformations unit, and it might be easier to use this new technique. So the new technique says graph the inside. Well, that's y equals mx plus b. It has a negative slope and a y-intercept of 2. So here's my line. Again, this is where it's equal to 0. This is where it's equal to 1. This part is above, and after that's below. So I could graph it using the new technique. How would you do that one with transformations? You got to factor, right? Because there's a negative and a horizontal translation. So if you factored it first, there'd be a negative, and then it would be x minus 2. So the negative would, if you started your graph, if this is what your square root graph starts with, the negative would flip it this way, and then finally you would move it 2 to the right, and you'd get exactly the same thing. But if you forget that negative factoring out, you're going to make a mistake. So maybe graphing the line first and using the new technique would be better. All right. So here are just some things to summarize and highlight. We've talked about this, but we haven't highlighted this yet. So 0 and 1, 1 and 0. These points don't change. So things that don't change we call invariant points. Between y and the x-axis, in other words, between 0 and 1, the graph is going to be above it. And whenever you're above y equals 1, the graph is going to be below. And finally, if you have any negative values, you can't take the square root of negative values, so that part won't exist.